This is the tutorial for Chapter 4, Section 3, Part 3. So we're using all the different components to this section to be able to solve these problems. So the first one asks us, two transversals intersect two parallel lines. So I know the two lines are parallel because of these symbols right here, in which we have the arrows kind of through the line. And then the transversals, again, are the lines that cut through the parallel lines. And so we have to explain whether RST, so triangle RST, so this triangle right in here, is similar to VUT, so VUT. Now when they do this, they tell us, when they're asking us whether they're similar, the points here that represent this triangle should be corresponding with respect to the order that they end up giving it to us. And so R and V are corresponding. U and S are corresponding. T and T are corresponding because they're the same points. So what we can do is we can use an angle theorem to determine whether two angles are proportional. And so we're going to start off with SRT. And so I'm going to say angle SRT is congruent, so that means exactly the same as, now I have to be specific about the point that is corresponding. So if I started with an S, it means I need to start with U. So I'm going to do U, UT, let's see here, UVT. And so I had to do V next because it corresponds to R. So notice V is first in that representation of the triangle, and R is as well. And so the reason those two I say are congruent, because if you look at it, SRT is this angle right here, and then UVT is this angle right here. And since we have parallel lines and a transversal, these two angles are the same because they're alternate interior angles. And so that's what we write down here. So alternate interior angles. So we have to state a reason why we're saying they are congruent. And so we do that one more time. All we need is one more angle. And so I'm going to say angle UTV is congruent. So I started with U and I went to T to V. So I have to start with S because U and S are the same corresponding points. So I'll do STR. So STR, those are congruent. I can prove that because notice that they share the same vertex. They're talking about these two angles right here. And the reason why they are congruent is because they are vertical angles. And so now I can say that those two triangles are similar. So here's the way we write that. Triangle RST is similar to triangle, and then I restate that one, VUT, and the reason is by the angle postulate. And sometimes what they'll do is, instead of writing angle, they'll just say AA postulate. Now, a postulate just means something that we just state as true. Without proof, we know that that's true. And then we're using the angle postulate to say that. So that is the first one there. And here we're supposed to explain whether the triangles are proportional. And so when we take a look at triangles being proportional, and we can say that triangles are similar if all corresponding sides are proportional. So again, triangles are similar if all corresponding sides are proportional. And so if I look at a side right here, AC, if it and its corresponding side, FD, and I know those are the corresponding sides because if I look at them, I go to the explanation of the triangle, AC is the first and the last points that represent this triangle, and I know it is corresponding to FD because if I look at those, D and F are the first and last points. So if I look at those two angles, or those two sides here, AC and FD, and I go ahead and write those as a ratio, 6 is to 2. That reduces down to 3 to 1. So I can check the next one. I'll check AB. Now AB corresponds to, well, AB is right here, the first two, so it's DE. So D to E. And so if I look at that, AB is 9, DE is 3, and you see how those simplify to 3 to 1. And if I look at the last one here, B to C, BC is right here, and if I look at its points with respect to how I named it, BC are the last 2 points, E and F are the corresponding points, EF are corresponding sides, and that ratio is also 9 to 3, which reduces to 3 to 1. So notice all of the ratios are 3 to 1. And so what we can say is this. All corresponding sides are proportional, therefore triangle ABC is similar to triangle DEF. And so again, as long as the corresponding sides are proportional, then it is, and all corresponding sides are proportional, then the triangles are similar. Well, in this next theorem over here, what we're looking at is angles. They don't give us the sides, so now we have to look at the angles, and we're going to try using the angle postulate. So I don't have all the angles, so again, just as we had done in the other parts, we have to subtract the sum of the two that we have from 180 to find out what that other missing angle is, because I don't see similar angles, but I do see J and G both have an angle of 68. So we continue here, and I'll sum those two numbers, and I get 138. And when I go ahead and, again, I'm summing those 68 and 70 to make 138, and when I subtract, I end up with 42 degrees. So this angle is 42 degrees. Now notice that G is 68, H, at point H is 42 degrees. Well, that matches what we have here. See, K is 42 degrees, J is 68 degrees. So what we can say is triangle GHI is similar to triangle JKL. And here's our reasoning. So what we can do is state because and then I'll state it down here, because two angles in one triangle are congruent to two angles in the other triangle. Right, and let's take a look at the next type of problem. And actually, we're going to go ahead and make another tutorial for that last type of problem. So check out part B for the last type of problem that we'll end up seeing on tonight's homework.